Hey guys, today we're going to be talking about direct proofs. We're going to be talking about how to identify when to use it, the steps you need to directly prove something, and then we're going to go through an example. So let's get started. So, given the statement, if P, then Q. If you want to prove this, let's first assume that P is true. Then you can use that to prove that Q is also true, proving the whole statement. So it's pretty straightforward. So let's go through an example. So we want to prove that if n is even, then 3n plus 5 is odd. Okay, so before we go with our proof, we want to make sure we understand what an even and odd number is. So an even number is defined as a number, let's say, look, okay, let's pretend it's n. So if n is even, then it can be described as 2 times some integer k, because if it's even, it's like divisible by 2, right? So if it's divisible by 2, it can be represented as 2 times some integer. And then an odd number is defined as 2k plus 1, because you know that every consecutive integer is goes through odd then even. So we can just describe it as an even number plus 1. So we also need to make sure that a is an element of the integers. So that's just like the simple definition of odd and even numbers. We can identify our P and Q by being P if n is even, then Q. 3n plus 5 is odd. So let's assume that n is even. Okay? So by assuming n is even, we can say n is equal to 2k. So if n is equal to 2k, then 3n plus 5 is equal to 3 times 2k plus 5. So by just doing some more algebraic manipulation, we can get to 6k plus 5. We want to show that q is odd. So we know that the definition of an odd number is 2k plus 1. So let's factor this out using algebraic manipulation to try and get that particular form. So we know that 5 is equal to 4 plus 1. Okay, so we can now factor this out to become 3, 6 plus 2 plus 1, which is the same thing as this. So this is our proof. We just showed that this equation here is able to be represented by 2 times some integer plus 1, because we already stated earlier that k is an integer. 3 times an integer is still an integer. Add 2, that's still an integer. So we can just make it simpler. So we can set this 2k2 plus 1, where k2 is equal to 3k plus 2. And that's our proof.